In this module, we'll cover all things JSON as it relates to SingleStore. We'll first begin by providing an overview on JSON data and discuss why it's important for your database to be able to work with JSON data. Then we'll dive into the DDL, or data definition language, for creating tables with JSON columns and how we might add indexes to JSON data. And then, of course, actually working with JSON data. That's inserting, reading, and updating. There are a handful of built-in system functions in SingleStore that make dealing with JSON data easy, and we'll be sure to cover that in detail as well. So first things first, what is JSON data? JSON, which stands for JavaScript Object Notation, is simply a standardized format for structuring your data. JSON is an extremely common format, particularly for data exchange between servers, APIs being a primary example, but at its core, JSON is just another way of storing and structuring your data in easily readable and accessible ways. And the way JSON implements structure is with key value pairs. The value, of course, being your unit of data, and the key being the means to access that data. So in this simple example JSON here, we are storing the string of string value with a key of key name. We can add more data to this JSON object by simply adding another key value pair separated by a comma. So we can see here that we have two values being stored, string value and hello world. We can read the values from the JSON object by using the key associated with the value. So here we are using the key name key to read our value of string value. So here's an example of some actual data about a person being stored in a JSON object. As we can see, the values are not restricted to just strings, but they can be numbers as well. In fact, the value in a JSON object can even be nested JSON objects or arrays within arrays. We can see here that this user's favorite team is the Eagles, but in the case that a user may have multiple favorite teams, we can store all of them in a single array value like so. And we can extend this even further. Perhaps we want to provide a little more context for those who are not sports fans, so we can store these values in objects within the array with descriptive keys defining which sport these teams belong to. So you can see by the way we can format our values to fit the needs of our structured data, JSON doesn't adhere to any general schematic principles. However, it can be very important for your relational database to be able to handle the schema-less data, and SingleStore allows us to easily do that by being able to store JSON in its own column type. This becomes particularly important when dealing with data that could be stored in a single table but has a few aspects that are diverse and may result in needing multiple tables that are sparsely populated. For example, suppose a company had an asset management application using SingleStore to track all of the information about its physical assets like laptops, business phones, and company cars. Each of these assets would have similar attributes in your database like an asset ID, the name of the asset, and a description of the asset, but each of these items would have properties that are unique to them. You might want to store the processor or the amount of storage for each laptop asset that's distributed. You might want to store the brand or carrier for the business phones, and for the company cars, you might want to track the mileage and the license plate for each car. Instead of having individual tables for laptops, phones, and cars that are sparsely populated with much too granular data, you could store the unique attributes of each asset in a JSON object called properties.